So we are going to see the various types of power amplifiers which are available in practice which are developed using class common emitter amplifier only. So we are going to take common emitter configuration as our reference, and we are going to design several power amplifiers, or it is also called as large signal amplifiers. So we in our syllabus we have four types: class A, class B, class AB, and class C. So we have these four types of power amplifiers in our syllabus: A, B, AB, and C. Okay, so conventional amplifiers and large signal amplifiers, what is the difference? Okay, so as the name indicates, large signal means the input to the amplifier will be having a larger amplitude. So whenever you are going to amplify this signal, the output will be even more larger. So when the amplitude of the signal is going to be larger, the power is going to be enormous. So that is why these large signal amplifiers are called as power amplifiers, because it is just like they are going to amplify the power, because voltage and current are amplified enormously because the input to the amplifier is large in magnitude. So the output will be even more larger. So it is called as power amplifier. And what is the need of having these power amplifiers? So I want to deliver a huge amount of power to the load. So when applications demand delivering huge amount of power to the load, in those cases conventional small signal amplifiers will not work. So you have to definitely design a new family of amplifiers called as large signal amplifiers. Small signal amplifier, the signal level will be in the order of millivolt. So input will be millivolt, output will be volt in small signal amplifier. So you will be using many models, H parameter model, hybrid pi model for analyzing all the amplifiers. In large signal amplifiers, the input itself will be in volt and output also will be in volt. So if the input is 1 volt, output will be 1000 volt. It is very, very large. So power is V square by R. So when you find the power will be very, very large. But in conventional small signal amplifier, the power will be in the order of milliwatts only, because the output voltage will be in the order of volts only. Okay, so it will be in the order of milliwatts or watts. But in large signal amplifiers, the power will be in the order of hundreds of kilowatts. So the transistor is going to deliver enormous amount of power at the collector end. So if I want to transfer that power directly into my load, I'm going to go for large signal amplifiers. Okay, so you know that the basics of Q point and everything. So since we are focusing more on getting enormous power, so we would be operating the device in the non-linear region. Except for class A, all other amplifiers will not have Q point exactly at the center of the load line. If the Q point at the center means the active region operation takes place and amplification happen. That is only for class A amplifier. When you take class A, B, and class C, the Q point is not exactly at the center. The Q point is either towards saturation or cutoff. So I can say the transistor is going to operate in the non-linear region. Okay, so in that case, only the approximate results can be obtained. You cannot have methods to get the accurate results. Okay, since I am not operating in the linear region. So the maximum power rating of the transistor also has to be considered. So when a transistor is manufactured, the manufacturers will give a data sheet. That data sheet will have the maximum power rating of transistor, which means that the maximum power the transistor can withstand without being damaged at the collector side, because output is taken across the collector, right? So maximum power rating means it is the maximum power the transistor can withstand without getting damaged. When the power is going to be enormous, the temperature will also be large. So it can be said in terms of temperature also, the maximum device temperature the device can operate without getting damaged. So either you can say the maximum power rating in terms of power or in terms of temperature, because the larger power causes the temperature to rise. Okay, the types of power amplifiers are class A, class B, class C. Even you have a class D, E, F, G, H, I, J, K, L. Till L you have class power amplifiers, but we are going to restrict ourselves to the study of class A, class B, class AB, and class C. and ultimately we will see what is the difference between each class of amplifiers. And remember, all these amplifiers come under the category of large signal amplifiers, and in large signal amplifiers the input to the amplifier is in the order of volt, and the output is amplified version of the input, so it will be hundreds of volt. So their power delivered will be very very huge. That is the reason why I am going to go for large signal